Morning to everyone. Since it is Saturday, only 6 people have joined. Okay, however, let me start my work with respect to the class. So today we would like to recall the SR latch one more time. So this is wait. This is SR latch, and SR latch only one specific problem with SR latch is so this particular latch does not have any clock pulse, does not have any enable. So it is not supposed to be enabled without attaching the electricity to this particular SR latch. So because of this reason, so SR latch will not be work out anymore. And here you need to remember one more thing. In SR latch, as and when 00 will be there, then it will be considered as indeterminate state. Whereas if you are supposed to come across with SR flip-flop, latch is different from flip-flop. Okay, so look at this. What is the flip-flop? How this flip-flop is being worked out here? Let us have a look here. So SR flip-flop, this is actually latch, and this latch will be further connected with the two more NAND gates, and one NAND gate must be connected with S, and the second NAND gate will be connected with the R, and second input of these two NAND gates are enable. Enable in the sense this is the electricity. Electricity has been given. So if electricity, enable bit will be equal to 0, so this total entire logic diagram cannot be work anymore because there is no electricity which is being passed. Electricity in the sense, if it is 0 and here also 0, no data is being transmitted through this particular logic. So therefore, you could consider whatever the outputs you have with you, these outputs are not supposed to be taken into consideration because there is no enable here. If enable will be equal to 1, for example, this enable could be considered as 1 here, then electricity has been passed. Yes, this could be activated. This could be activated. And working procedure, working will be gets activated here. And this is also activated, followed by this one also. Finally, you could get some kind of output here. So without having electricity, so-called devices could not be work anymore. They will be in switch off mode. So that is the importance of a flip-flop here. Flip-flop is always expected to have some enabler. That enabler will be connected to power generator. Battery, simply speaking, some battery. So if you do understand the SR latch, it's very easy to understand this SR flip-flop. Look at this. In previous video or previous class, we have discussed something. If 0 will be passed here, let me say at this place. I'm not talking about this area. I'm not touching about this particular area at this moment. I'm talking about SR latch. So if you are supposed to pass 0 here, we got one value Qn equal to 1, Q complement n also be equal to 1. So this particular case could not be, it never existed because ordinary form equal to 1 and complementary form also equal to 1. It never exists in the world of binary. So therefore, that kind of situation is called as indeterminate situation or forbidden situation. Okay, in terms of talking something about latch. Whereas if you are talking right now, if you are talking something about so flip-flop, two more extra NAND gates are being connected to this particular latch. Look at this. So here it has been passed 0. It has been passed 0. However, value of this one and value of this one must be always equal to 1. So basic output of a NAND gate will be when two inputs will be equal to 1, then it will be output will be 0. Either of inputs will be equal to 0. Let me say 0, 0, both are zeros, output will be equal to 1. Or 0, 1, output will be equal to 1. and 1 0 output will be equal to 1 here. So whenever two inputs will be equal to ones, the output will becomes 0, and remaining all other situations, the output will be equal to 1 here. Okay, so based on this particular principle, which is being actually operated by NAND gate, we have to operate here. So here the output of this NAND gate will be 1 here, and output of this NAND gate, let me say, so this is first NAND gate, this is second NAND gate, third NAND gate, and fourth NAND gate. Stage 1, 1, 2, stage 2, 3, and 4. And output of this NAND gate also be 1, 1 here. Okay. If you pass 1, 1, we know 1, 1 will be always taken no change. Look at this. Look at this. So have 0, 0 has been passed at first gate and second gate. You may be get 1, 1 as input. Look at this. Input for Qn plus 1. At this place, you need to identify the Qn plus 1 here. N plus 1. This is Q. So N plus 1 whole complement here. This could be identified here. So here, previously we have taken 0 here. Previously again we have taken 0 here. This place is 0 and this place also be 0. I will show you that one so soon after completion of this explanation. Okay, here we have taken as 0, 0 previously. But here, second stage has been implemented by making this latch into flip-flop. So flip-flop will be converted into, latch is being converted into flip-flop by incorporating this particular, let me draw something for you, then you could understand. By incorporating this second level gate, and also by incorporating, so this electricity, I mean power generator. By implementing these two, so second level has been taken into consideration, and the basic operations which have been given by NAND gate will be, so if 1, 1 will be gets passed, then output will be 0, and remaining all other situations output will be 1 for a NAND gate here. So that 1, 1 has been passed. In SR latch, if you remember or if you recall yourself, in SR latch, as and when inputs will be, both inputs, S will be equal to 1 and R will be equal to 1, so the output might be not changed. There is no change at all. If you recall yourself regarding to functional table of SR latch, if 1, 1 will be taken as input, then there is no change. Even then you have been passed 0 and 0. So because of this first level two gates, zeros will be converted into ones here, so that 1 into Q complement N whole complement equal to Qn, 1 into Qn whole complement equal to Q complement N. Whatever the previous outputs, the same outputs will be regenerated in terms of so next type here. So Qn plus 1 could also equal to Qn, and Qn plus 1 whole complement could also equal to Qn whole complement. Whatever the previous states, they will be continued with the next states also. Why it was happened like this in the sense? Because of this second level incorporation of the gates. If second level incorporation of gates will not be existed, if these could not be existed, obviously what we are supposed to specify, what exactly we are supposed to take into consideration here in the sense, S will be directly connected to third gate and R will be directly connected to fourth gate. So if directly connection to third gate and fourth gate, that will be considered as a latch, not flip-flop. So if directly connected to third gate and directly connected to fourth gate, so that you don't have any further input here, that input is enable. Enable does not there with you. So therefore that is called as latch here. So that is the difference you need to understand. So finally, if S equal to 0 and R equal to 0, what exactly we are supposed to get? Whatever the previous states of outputs, same outputs will be continued. So that is why it is called as a no change state. Whereas if you, I'd like to repeat, whereas if you take the same state in terms of latch, it is indeterminate. It is indeterminate in terms of latch. In terms of flip-flop, it will be considered as no change. S equal to 0, R equal to 0 will be taken So previous outputs will be continued. Whatever the value of Qn and whatever the value of Q complement 1 will be continued for next outputs also. So that is what the information. And secondly, if you send the data as 0, 1, if you send the data as 0, 1, so let me erase everything and I will come back to you one more time. So here it is 0 has been passed and here it is 1 has been passed, here it is 1. Okay, enable is always 1. So 0, 1 will be there, obviously the output will be 1. So because of all arrays, it has been erased here. So NAND gate will be, both inputs will be equal to 1, then the output will equal to 0. And remaining all other situations, outputs will be equal to 1 here. This is the basic operation of 1, 0 or 0, 1. So all other situations, you do have 1, 1 here. Here also you could have 1. You need to remember this particular truth table of NAND in your mind. Based on that, you have to work out. So here S equal to 0 and R equal to 1. So both are ones in the sense here we have passed 0 and 0, 1 as per the so NAND gate original truth table. So sorry, not this one. This one I think this one 0, 1 will be taken. So final output is 1, 0. 1, 0 will be taken by so this level. So this third and fourth level kind of gates here. So here Qn plus 1 will be taken something like this. Qn plus 1 equal to 1 into, so here 1 into, so Q complement N whole complement. 1 into Q complement 1 whole complement, that will be equal to Qn. So how it could becomes in the sense? So 1 into Q complement N will be equal to Q complement N only. So 1 into, so Q complement N will be equal to, so Q complement N, Q complement N. And if you apply whole complement in the sense, A complement whole complement will be Qn. Okay. How it will becomes, let me explain for a while. After some time, after completion of this one, let me explain why it is 0. So Qn has been occurred here. Now followed by Qn plus 1 complement, whole complement equal to, so 0 into whatever the value you have supplied here. So that is Qn, 0 into everything is 0, 0 complement equal to 1. So here we got 1. So obviously this 1 will be submitted here. So 1 into 1 whole complement, that is 0 here. So that is the way you need to consider. Otherwise, you may be evaluate this one first, followed by this one. Any one of these will be okay. You could get good marks in your final examinations. Let me repeat one more time. Let me repeat this particular stage one more time. So let us consider this is the specification where exactly you need to consider. So let me explain Q complement N at this area here. So this is, I'd like to identify Q N plus 1 whole complement first. Let me identify this one here. So what is the input of this one? This is the fourth gate, that is this NAND gate output will be, this NAND gate output will, both inputs of second NAND gate is 1, 1, so that you could get a 0 as output. Yes, output is 0 here. So 0 into input of this line will be, input of this particular line will be, so Qn. So finally 0 into Qn whole complement is equal to 0 into anything will be 0, so that 0 complement will be equal to 1 here. This is 1. And this 1 will be submitted here. So here 1 will be submitted. So second input will be 0, this NAND gate. First NAND gate output will be 0, 1 as input for first NAND gate, and output will be equal to 0. So, sorry, not output is not equal to 0, it is 1 actually, sorry. This is 1 actually. So 1 into 1 whole complement. 1 into 1 whole complement. 1 into 1 whole complement equal to 1 complement. 1 complement equal to 0. So this value equal to 0 here. So like this, Qn will be having, so 0, and Q complement value will be Qn plus 1 complement value will be 1 here. So as and when R will be equal to 1 and S will be equal to 0, the system has been resetted. So it has been goes with a reset mode. Okay, then if you send the values like this, so let me change the values for a while. Then you could come across some other kind of inputs here. Inputs might be seems in such a fashion. Inputs might be seems in such a fashion here. Let us have a look here. Let us have a look for this particular thing. Okay, so if you change the inputs, s equal to 1, s equal to 1 and r equal to 0. Now it is 0. So since it is s equal to 1 and r equal to 0, enable is always equal to 1. 1, 1 will be leads you 0. Output of first NAND gate is 0. So 0, 1 leads you, here it is 1. Now you need to identify this particular value at this moment. So this particular value could be 0 into qn complement. So here qn whole complement. So this value will be, so 0 into, okay, I already have written here, 0 into qn complement whole complement. So anything with multiplied with 0 will be 0. 0 complement equal to 1 here. So finally, so you will be get a particular value here, that is 1. Submit this particular value 1 at this fourth gate. So this is also 1. 1 and 1 are 1 into 1 whole complement. 1 into 1 whole complement will be, qn value is 1 and this value could be submitted here. So 1 into 1 whole complement will be equal to, so 0 complement, sorry, 1 complement, which is equal to 0 here. So this will becomes as 0. So as and when s equal to 1, s value equal to 1, so your entire, so flip-flop will be set to 1 here. Okay, so therefore, this is called a set position. And the previously it is reset position. Qn value equal to 0 and the Qn complement value equal to 1. So that this is called as reset previously. Right now, it is set position. And finally, it's very important to observe this final operation. So that is, this value is 1 and this value is 1. Obviously, this value is 1, enable value also be equal to 1. As and when 1, 1 will be supplied to a NAND gate, the output must be 0. So here also R value also 1 and enable value equal to 1. So obviously the output of this one is 0. So we are talking about, this is the fourth case, we are talking about case number 4, both will be equal to, so 1, then 0, 0 will be taken as, so lower level NAND gates here. This is lower level of the system, this is the third one and this is the fourth one. Okay, you can name it as like anything. So at the third, input will be 0 and I have to submit it. So 0 into q complement n whole complement. 0 into anything will be equal to 0. 0 complement equal to 1 here. You could get 1 here. And then one of the inputs, you may be supply this particular input 1 here instead of q n, 1 will be submitted here. 0 into 1 whole complement. So 0 into anything will be 0. 0 complement will be equal to 1 here. So here also 1. It does not existed at any moment of time. It never existed. So ordinary value and the complementary value never be same. This case does not existed. So that is why this is called as indeterminate state. Indeterminate state. You can observe this one. If enable will be equal to 0, nothing is there. No operation will be took place here. Okay, if enable equal to 1, continuously it is 1 in the sense, yes, battery has been working properly. Now 0, 0, 0, 1, 1, 0, 1, 1. If 0, 0 will be supplied, in SR latch 0, 0 case will be indeterminate. Because of these gates, these two gates, 0, 0 will be converted into 1, 1. So that is why no change state will be there. And 1, 0 will be reset and 0, 1 will be set. And 0, 1 will be reset and 1, 0 will be set state, followed by 1, 1 will be indeterminate state. So whatever the discussions we made in SR latch, some quite opposite discussion will be took place in SR flip-flop. You need to remember. You need to remember. This quite opposite operation will be took place because of first level NAND gates, NAND gate 1 and NAND gate 2. because outputs will be always gets flipped. So that is why you could get this kind of a functional table. Okay, this is what about SR latch. Sorry, SR flip flop. Sorry, SR flip flop. In SR flip flop, so you have either it is SR latch or flip flop. You have a state. That state will be so indeterminate state. Then how could you eliminate this one? Because manually or electronically, people maybe give some kind of input. Input must be always manual. There must not have any electronic kind of input. Only manual input must be there. So knowingly or unknowingly, any user maybe give some kind of input in terms of 00 by SR. Obviously, your total logic will be failed. It may becomes to forbidden state. So because of a forbidden state, so your latch or SR flip flop cannot be worked properly. Then how could you eliminate this one? How could you eliminate this particular kind of situation in SR latch? So there is one possibility how it could be gets eliminated. That is D flip flop. So only one input will be there. Let us look at this particular logic diagram. Only one input is there with me. That input is D, and this D will be flipped and submitted to first level inputs here. So this is gate number 1, and this is gate number 2. This is gate number 3, and this is gate number 4. Look at this. Only one input is there. That is D. If I submitted 1 here. So because of NOT gate, it will be goes as 1. So here directly 1 will be taken, but here it is 0. If I submitted 0, for example, if I submitted 0 here, obviously because of 0 will be sent to NOT gate, here we will get 1. Okay, so here it is 0, and here it is 1 will be occurred here. So therefore, single input, because of this particular single input, so since a single input is there with us, so that the single input will be gets flipped and submitted to second gate here. So therefore, you never come across 1 1 or 1 0 0. You never come across those two states, because if 1 will be submitted and second bit will be taken, its complementary form, that is 0. If 0 will be submitted, second bit will be taken, its complementary form 1. So therefore, 1 1 and 0 0 cannot be taken by single input, either 1 1 0 or 0 1. Only these two states will be taken. And of course, one more input is very much important, that is enable. Enable must be always equal to 1. That must be there. If enable could not be there, your entire logic could not be worked out here. So it must be always 1. Look at this. It must be always 1. Now, let me explain what are the different cases which are existed here. So, first case will be if D equal to 0. If D will be equal to 0. Yes, I have been submitted here, it is 0. And of course, 0 will be took place from this particular direction also. 0 will be flipped here. 0 will be complemented here. 0 complement will be equal to 1. Now, 0 1 output is 1 here. 1 1 output is 0 here. Okay, the same similar kind of activity will take place here. Qn plus 1. At this place, we need to identify Qn plus 1 will be equal to, here it is one of the inputs will be 1, and the second input will become so this particular area. So this way, Qn plus 1 equal to 1 into Q complement n whole complement. That is 1 into Q complement n equal to Q complement 1. So sorry, Q complement n. Q complement n whole complement equal to Qn. How it comes to 0, let me explain after a while. Just wait for one moment, I will explain. And if you execute this one first, 0 into Qn whole complement, 0. One of the inputs is 0, and the second input will be here. It has been comes like this. 0 into something will be equal to 0. 0 complement equal to 1. Now here you have to submit 1 here. That is the meaning here. Okay. So it has been equal to 1. So 1 into 1 whole complement, that equal to 0 complement, sorry, 1 complement, which will be leads you 0 here. So this is eligible kind of activity. Okay. Then second case will be when D will be equal to 1. Now D will be equal to 0 is gets over. Now we'll come across with D will be equal to 1. If D will be equal to 1, what exactly you are supposed to apply here? What exactly you are supposed to achieve here? Let us have a look and let us examine each and everything here. Okay, so take this one at this moment. So if it is equal to 1, so here I have been submitted, here 1. So because of this complementary, instead of this 1, I have taken 0. So here there is no 0 actually, 1 and 1. Because of 1 and 1, output will be equal to 0. Because of this is not there here, because of 1, 0, output is 1 here. So here, because one input is 0, any input which will be taken here, this must be equal to, seems like this, qn plus 1 will be equal to 0 into q complement n whole complement, 0 into this particular quantity will be equal to 0, 0 complement equal to 1 here. You got 1 here. Then followed by this 1 will be submitted here, 1 into 1 whole complement, that will be equal to 1 complement. 1 complement must always equal to 0. Yes, it is eligible. It is also eligible combination because so Qn equal to 1 in the sense its complementary must be equal to 0. Or Qn equal to 0 in the sense it must the complementary form must be equal to 1. So that is why 0 0 combination, 1 1 combination has been eliminated. Because of these two has been eliminated, obviously, so you have been eliminated in the determinate state, otherwise forbidden state temporarily. But most of the cases, you are expected to apply so two inputs rather one, two inputs must be applied. So if that case will be, that is the so exact case where exactly you have to apply D flip flop cannot be worked out anymore. Okay. However, this is the functional table. So this is the functional table. So enable will be equal to 0, nothing will be happen, nothing will be gets happen. Enable equal to 1 in the sense continuously the electricity has been passed. Then if it is 0, q complement equal to 0 and q equal to 0, q complement will be equal to 1. So therefore that is called as a reset state. And if it is 1, d value equal to 1, then q equal to 1. Just before we have come across, we have a team. So q complement equal to 0. So therefore that is called a set statement, set state. So from SR flip flop, how can you eliminate this indeterminate state or forbidden state is instead of supplying two inputs, supply only one input, and for the second gate, same input will be flipped, otherwise complemented and supplied. If you do like that, so you may be eliminate indeterminate state. Indeterminate state will be gets eliminated. This idea is good. There is no problem at all. This idea is good only, but this idea could be bad. This idea could be bad when your specification or logic must be accepted. Two different types of inputs. Input number 1 and input number 2 must be given to your logic. This idea could not be useful. And SR flip flop also, S and R will be taken. Thereby, one problem is there for 0 0 0 1 1 0 1 1. For 1 1, there is no, sorry, for 0 0, there is no problem. For 0 1, there is no problem. For let me back to that particular area, then you could understand. So for 0 0, there is no problem at all. For 1 0 0 1, there is no problem. But 0 1, there is no problem. But as and when you have to come across with this particular state, you are facing some problem that is indeterminate state or forbidden state. So since this forbidden state, this SR flip flop cannot be worked out for all kind of situations. Then what shall we have to do? Okay, two conditions. I am giving two conditions here. Condition number 1, if you are supposed to implement your logic using SR, something like this, SR does okay with these combinations. SR will be gets okay with these combinations. Sorry, yeah. SR will be worked out with so these specific combinations here. Combination number 1. So 0 0, no problem. Output will be so specific output will be comes out here, and then 0 1 there is no problem. So it will be goes to reset state. 1 0 also there is no problem, set state. But your unfortunately you may be submute submit. So 1 1, obviously you could get some indeterminate state, otherwise a forbidden state. If forbidden state will be gets occur, your entire logic will be goes wrong or fail. So this is the problem with SR. And if you want to eliminate this intermediate state, sorry, indeterminate state, you have tried with this particular thing. That is, single input will be sent to that particular entire logic. So therefore, the 0 0 and the 1 1, these two combinations are eliminated. So your combinations might be only 2 1 0 or 0 1. Only these combinations will be there with you. Because of these combinations, so forbidden state will be gets eliminated. Okay. So even then that is eliminated, if your design will be required, you must be submitted two different inputs. For example, SR will not support you, SR will not support you, and for that you have implemented D. D is working okay, it is working properly, it is okay, but even then, two specific inputs will be expected to implement by using your flip flops. So both of these are not supposed to be worked out properly. Then what shall we do? So what shall we do in the sense, we'll go ahead with the JK flip-flop. Some more extra so implementations are there in JK flip-flop to eliminate the forbidden state from SR flip-flop here. How it could be gets eliminated, we will look forward everything by tomorrow class. Okay. Sunday also we do have a class. I will finish off with JK and one more flip-flop, that is JK. I'd like to finish by tomorrow in the morning. Okay. If any questions, you could ask me at any moment of time. I shall be available up to 5:30. I shall be available up to 5:30 and online. So you must be post any kind of question through your WhatsApp or WhatsApp group or your personal WhatsApp to me. So I will come to online and I will rectify your questions. I will answer your questions. Okay. This is what today's class.